Hello everyone, my name is Abdurrahman Mohammed. Today we will present for you our Capstone design project with my colleague.
Hello, I am Mohammed Adil. Today we will be going through CO2 capture system by amine absorption. In the beginning, I will talk about what we will be discussing in our presentation. We will start with a brief introduction about the amine absorption for carbon capture system. Then we will talk about the absorption process description. Then we will move on the material balance. After it, the Aspen simulation, then absorption column design. Later, we will compare the manual design and the Aspen HYSYS. Then talk about the equipment cost analysis. And last but not least, we will talk about the health and safety environment. The CO2 capture technology that we have used is the amine absorption. This technique is widely used in the industry and commercially while taking into account many factors like absorption rate and efficiency. The amine process with monoethanol solvent was used as scrubbing agent in our project. I would say that monoethanol amine solvent is used worldwide and is commercially available, which make it easy for us to find and get our hands on it. Here is the overall material balance of all stream entering and leaving. The material balance tell us about the process efficiency and the amount of product being produced or wasted. It is done at steady state, which mean the combustion is not changing with respect to time. For designing purpose, all the values selected in our material balance to perform the design simulation and manual design. Here in this slide, you can see the parameters that we used to grade this whole process. We used this number shown in the table as feed. We have two feeds, the liquid feed, which contain amine solution with water, and the vapor feed, which contain the flue gas. In this slide, you can see that all equipment are available, and it was a huge success to us in regard to the Aspen HYSYS simulation. And for the manual design for absorption column, we will take those values from Aspen HYSYS from both stream, amine solution, and feed gas. The values that we will take are the density, mass, flow rate, viscosity, surface tension, pressure, temperature, and molecular weight. By starting the design, the first calculation is to find the first diameter of the column, and we do that by obtaining the K4 from this graph. After that, calculating the gas mass velocity, and in the third step by this equation, we will obtain the area of the column, and finally by applying this formula of the diameter, we obtained it, and it was 11.1 meter. The second design calculation, it will be about the height of the column. I will go through it step by step. The first step is identify the effective interfacial area, and then we found the liquid mass transfer coefficient, and after calculating those two, we can now calculate the gas film mass transfer coefficient. Here we go we go in and calculate the height of the gas phase transfer unit, and then the height of liquid phase transfer unit, HL, and then we can apply the HOG formula, which is the height of the transform unit being equal to 14.8. After that, to calculate the height of the tower, we obtain the number of the transform unit in the graph as shown, which is to be 1. And finally, the height of the tower will be 14.805 meter. Now, my friend Abdurrahman, he will continue the presentation.
Now it comes to mechanical design to determine the thickness of the absorber. Firstly, we measure the design pressure as shown by applying the formula. After that, the thickness of the column can be calculated, which is 6.58 millimeters. Here is the height and the diameter of the column designed from Aspen Hysis. Diameter equal to 12.1 and the height equal to 14 meters. Talking about the comparison between Aspen Hysis and the manual design, I would say the both designs were so close. As you can see, we obtained the percentage error for the diameter to be 9% and for the height of the column to be 5.4%, which is acceptable. In cost estimation of the equipment, first of all, we find purchased equipment by using cost indexes, and cost of the equipment is finding out by using the formula. From the left, we obtain the K1 and K2, K3 factors from the table and the size, which is the area of the column. And on the right, it shows the graph that we obtain the index cost. Here is to show our solution of the equipment cost, which is 1,600 USD. Lang factor is estimated ratio, the total installed cost of the equipment to the equipment cost. We got it to be 4.74 from this figure, and we have the total cost which equal to 7,700 USD. All these costs determined from the table, and we have assumed the cost percentage between this range shown in the table. And we determined all those costs, variable cost, working capital cost, and extra. Talking about health and safety environment in the plant, the efforts and the procedures to identify the workplace hazard is by workplace assessment and following the procedures are given from the supplier. We buy toxic chemicals and by installing hazard signs like toxic gas sign and physical hazard sign. Labor training for accident prevention is as followed. They should know whom to report firstly if emergency happens. Also showing the navigate evacuation routes in case of exposure, and knowing how to shut down the plant, and also the proper way to wear PPE and when it's necessary. Here is the poster we provide to summarize our project and to make it easy to read. Thank you everyone for listening.